Welcome to you all in my YouTube channel Experience Mathematics. In today's video, I am going to explain you about partial derivative, and I am giving you the shortcut process to find out implicit differentiation using partial derivative. Before starting, I want you to make sure that you subscribe my channel if you have not already subscribed, and share this video with your friends, and also press bell icon so that you will be informed about my coming videos. Now I'm starting my today's topic, partial derivative. Let f equals to x square plus y square plus 3. Then here partial derivative of this function f x square plus y square equals to 3. You can write f in bracket x comma y also to this, and this is denoted by del f over del x. Okay, and partial derivative of this function with respect to x means derivative of this expression keeping this other variables except x constant. Okay, so here we will find out the derivative of x only. We take this other variable y square as constant, and this is also constant. Okay, taking variables or constants, all are constants except variable x here. So its derivative with respect to x will be like this. That will be derivative of x square is 2x, and derivative of all this will be 0 because except variable x, others are taken as constant while finding out partial derivative. So this del f over del x, we can denote this by fx. Similarly, partial derivative of f with respect to y, if we find out, at that time we take all variable except y as constant. So here we will find out the derivative of this y square, but we take this x square as constant. This is already constant. So its derivative, partial derivative will be 2y. This all derivative will be 0. Okay, in this way, this is the partial derivative of f with respect to y. We denote this by fy. Okay, so this simple concept of partial derivative will help us to find out implicit differentiation in shortcut way. That will be especially useful while solving multiple choice questions. Okay, because while solving multiple choice questions we don't have much time, and this will be very much helpful. So now look at one question to find out implicit differentiation. Use implicit differentiation to find dy over dx when ax square plus 2hxy plus by square equals to 0. Okay, we have to use implicit differentiation to find dy by dx when x square plus 2hxy plus by square equals to 0 is given. Okay, so to solve this, we suppose let f to be x square plus 2hxy plus by square. Okay, this expression to be the function fxy or f we can suppose, and if we find out partial derivative with respect to x, then we denote that by fx, and then its partial derivative with respect to x will be 2ax plus 2hy. Okay, here we have taken this y as constant, okay, while finding out partial derivative with respect to x. Similarly, partial derivative of this with respect to y, while finding out partial derivative of this with respect to y, we take other variable except y as constant. So it will be, derivative of this will be 0, and here its derivative will be 2hx plus here will be 2by. Okay, we have taken variable x as constant. Okay, so here derivative of this y with respect to y, dy over del y will be 1, and y square derivative, partial derivative, that will be 2y, so it will be 2by. Okay, I will show it here. Del y over del y, that will be 1, and then del y square over del y, that will be 2y. Okay, in this way, this x is taken as constant while finding out partial derivative with respect to y. So its derivative will be like this. And now ordinary derivative, dy over dx is given by minus fx over fy. This gives us ordinary derivative. So here minus fx, that is 2ax, so you can take out 2 common from this, plus hy over, from this also 2 common, fy, to hx plus by. And now this 2 can be cancelled, so our MCQ differentiation is minus x plus hy over hx plus by. In this way, using partial derivative in short way, we are able to find out implicit differentiation. Okay, so if we use a long process to find out implicit differentiation of the same question, then how it can be solved? Look at here. This is the shortcut process, and now our long process, see here. Okay, see the long process also. Just I explain short process, and by long process, how we will do it? X square plus 2hxy plus by square equals to 0. Differentiating both sides with respect to x. Okay, so here d over dx, x square plus 2hxy plus by square equals to d over dx and 0, and derivative of this will be x square derivative, that will be 2x plus 2h, and then 2h is constant, and derivative of this to find out here x dy over dx plus y d by dx of x, using product rule we can write like this way, plus b y square derivative is 2y, and then dy over dx equals to 0. Okay, so this long process is done by using ordinary derivative. Okay, so using ordinary derivative, the process will be like this. Here you have to use the product rule, and now 2ax plus 2hx dy over dx plus 2hy dx over dx, that will be 1 plus 2by dy over dx equals to 0. Now from these two is common, x plus hy, and this will go to right side, minus 2hx dy over dx minus 2by dy over dx. Okay, and now this implies 2x plus by equals to minus here 2 hx plus by, and then dy over dx will be outside, and now this 2 and this 2 can be cancelled. Therefore dy over dx will be minus ax plus by over hx plus by. Okay, and in this way, okay, here in this way we have got the ordinary derivative using a long process also. Okay, x plus sy. Okay, so in this way we have found out ordinary derivative using long process also. Here this is x plus hy, 2x plus hy, and minus 2 hx plus by dy over dx. From this we have taken out common, 2 dy over dx is common, and here remains hx plus by, and this 2 and 2 can be cancelled. Dy over dx will be x plus hy over hx plus by. We have got same answer using long process and by shortcut process, but while solving multiple choice questions it takes a lot of time, and if we just use the simple concept of this partial derivative, then we can find out its implicit derivative using shortcut process. It will save our time, and in short time we can solve more than one multiple choice questions. So the concept of this partial derivative, which is not in class 11 or in 12, it is in higher class, but it will be quite useful. It is easy and then useful while solving the multiple choice questions of different entrance examinations, especially in Bachelor's of Engineering examination entrance examinations. I hope that you found this video helpful, and if you have not already subscribed my channel, please subscribe it right now, and also share these videos with your friends, and also press bell icon so that you will be informed about my coming videos. Thank you for watching. Thank you very much.